So we just finished up with bottom-up and top-down processing, and now we're going to wrap up our basic 10 with number 10, which is that our environment, perception, is based on our brain's model of the world. So our perception of our environment, I should say, is based on our brain's model of the world. And what I mean by that, I'm really talking about unconscious inference. So we don't get all of the information necessarily that we need to interpret the world exactly as it is, right? We talked about the blind spot on the retina. We talked about how perspectives can make the proximal stimulus on our retina really different from what's actually out there in the environment, right? But we use all of that information to make inferences about what is going on in reality, right? So it's kind of like you find a bunch of dinosaur bones. You don't necessarily find all of the dinosaur bones, but you can put them together, make some inferences about what goes where and what might have been filling in the blanks, right? And you get a full dinosaur. Okay, it's very akin to our blind spot on the retina, like we talked about. So you can do that blind spot demonstration here again. Cover your right eye. I'm sorry. Cover your left eye, and then with your right eye, look at that cross. And wait, am I doing this correctly? Yes, cover your left eye, look at the cross with your right eye, and move backward and forward from the screen until that dot disappears. Then the lines themselves may not actually disappear as well, but the dot should disappear. So it's why we can see things like the Konica triangle, right? So this triangle, the white triangle that seems to be in front of everything else, it doesn't actually exist. That nothing about that triangle exists, but you can clearly perceive, right, the edges of a triangle. They don't just stop here with these little Pac-Men. Okay, you can perceive the edge of this triangle here. And it's because of the unconscious inferences that our brain is making about what happens when you have two lines that are obstructed by an image that seem to continue behind that image, right? So this is good continuity. So we're going to assume that there's an entire triangle behind here being obstructed by a triangle here, right? Like this situation, the gestalt of this situation allows us to make an unconscious inference about what is going on in our environment. Same thing here, right? You can see a Necker cube in this particular image. At least I hope you can. Let me see if I can get my handy dandy pen. So you can see the Necker cube here. Right. Okay, so there it is. There's your cube. Now, you can either see it as sort of a white Necker cube floating on top of the dots, right, which is how I primarily see it. Or you can see it as you are looking at the Necker cube. So the Necker cube is behind this slide, right? And I've punched these holes in the slide, and you can see that white Necker cube in sort of the black space that exists behind the slide. Can you see what I'm talking about? I don't know if you can make the image flip back and forth for yourself that way, but there's two different ways to perceive that particular image. So you have a bistable image here. Well, you have a Necker cube, so you have a bistable Necker cube on top of a bistable interpretation of whether that Necker cube is in the front of these black dots or behind this slide with you looking, peering at it through these little black holes. Okay, so you have a lot of stuff going on here. And really the only thing you have going on are these little black shapes. This little Pac-Man eating this guy, and this Pac-Man eating these two dudes, and this Pac-Man eating these guys, right? So that's all that's here. But because of what we are tuned to perceive in our environment, we can make inferences about the situation here that maybe we wouldn't make if we had different visual systems, right? That we definitely wouldn't make if we had different visual systems. Stuff like this, okay? You have, you show somebody, a subject, a picture, And later on, after they've done some other stuff, you ask them to draw the picture from memory. And they draw the picture from memory. And usually this is what they end up drawing, something like this. Notice the difference. Okay. We don't usually have a half of a trash can lid in our world, or a half of a trash can. Fences usually don't have the tops cut off, right? So what did they do? They drew things as we usually see. You can see the top of the fence. You can see both of the trash cans. You can see the full trash can lid, right? These are sort of extensions of what we know of the world that translate into our previous perceptions, right? This is the picture that I saw. I saw a couple trash cans with a trash can lid. I didn't consider necessarily the boundaries of that picture, because those kinds of boundaries are unnatural in my real world. And one last demonstration. What do you make of this jumble of pieces here? Right? Not a whole lot. Now what happens if I take an ink bottle and I pour ink all over them? Now what do you see? Now you see a bunch of bees. Now you're using rules like occlusion rules and figure ground segregation. Okay, that's stuff like what is a figure and what is its background. So you have this figure of the ink, and you know that these images are all in the background, right? So you group the ink together. Maybe you group pieces of these images together. Why? Probably because of good continuity between these lines, right? And because of this good continuity and the specific occlusion of the ink going on here, your brain goes, oh, well, that's a bee covered up by some black blob here. Okay, this is the magic of perception. Okay, it is a lot of rules that we have yet to understand in our visual system, a lot of rules for interpreting the stimuli in our environment, and our brain has evolved to follow these rules because we have lived in this environment. We've evolved in this environment. If we evolved in a different environment, we would have different visual systems. We would have different brains, right? The perceptual rules would be different. Okay. That's the basic 10. For future reference, maybe just have a look at some of the examples, pick a couple of your favorite examples, and make sure you understand how those visual examples, either illusions or whatever, how they demonstrate how the visual system works, not the visual system, sorry, how they demonstrate perception and how perception works. Okay, and then maybe I might want you to understand how two of these points sort of interrelate to one another. So for example, we actively organize our sensory information, right? And because of this active organization, a lot of times our perception, most of the time, will correspond to what's in the environment, the collection of input coming from our environment, rather than the precise imprint that it's making on our retina, right? So we don't necessarily interpret the tables as being the same rectangular shape because we have a bunch of context clues. We actively organize those clues, and those clues tell us that those are tables that exist in 3 dimensions, and because of that, because of the way the tables are drawn, they can't possibly have the same shape as the same tabletop shape, right? So that's how points 7 and 8 are linked, right? We actively organize information, which leads to a different interpretation of the environment, which corresponds more to the distal than the proximal stimulus. Okay? Okay. Just a little bit of wink, wink, nudge, nudge there. And then one final piece of food for thought. We see things not as they are, but as we are. From Anais Nin, attributed to Anais Nin anyway. No one is exactly sure where this quote comes from, but we'll say it's Anais Nin. Think about that. We see things not as they are, but as we are. We see the world with the machinery that we're given, not for all of the input that it has to offer. Think about all of the parts of the light spectrum that we are not able to perceive, right? Those are attributes of our environment that we just don't see, but they are out there. Imagine what perception would be like if you could perceive every single element of the world, if you could perceive every light wave, every sound frequency, if you could perceive all of that, every temperature. What would perception be like? What would our world look like if you could see things differently? And what does it mean that the world is not what we think it is, or rather, it's what we perceive it to be? Okay. Good interaction topic. I will see you in the next group of lectures, which I believe is memory, but I can't quite remember. Okay, see you there.